Hello, and welcome to the last pre-recorded talk. We have our helpful AV guys here as well, but this last talk is called Shipping Breaking Changes as the Most Downloaded Python Package. And here to give us our intro to our talk is Seth Michael Larson. He is the lead maintainer of urllib3. Tell me where you're located today, coming to us from.
Yeah, so I'm living right now in Minneapolis, Minnesota. So it's just starting to warm up a little bit, but it's pretty cold still.
Do you have snow over there, I'm guessing, or?
Yeah, there's snow all over the ground. This is actually a couple days ago was the first day above 0 degrees Fahrenheit for the 2 week span. So yeah, it's been pretty cold up here.
Wow, very nice. Well, welcome to PyCascades. I am going to point out that there's going to be no post-talk Q&A for this one, since it's the last talk, and we're going to go straight into the closing session. But Seth is going to be in Venulous in the chat answering any questions that you might have, so be sure to throw all your questions in there. And let's get started with our talk. Thank you.
All right, so I'm going to be talking about shipping breaking changes as the most downloaded Python package. So if you're like me, if you're reading that title, it's really clickbaity. It probably gives you a lot of anxiety. So what sorts of things can popular dependencies do to minimize the chances that they impact the broader Python verse? I'm going to talk about what the journey looks like for urllib3 and some things that maybe you can learn from about what the team did. So this XKCD comic is one of my favorites because it describes the situation for urllib3 perfectly. urllib3 has been downloaded 2.5 billion times from the Python package index, making it the most downloaded package. I've listed some other Python packages I consider foundational for the Python ecosystem for comparison. Now, urllib3 being the most downloaded Python package means that pretty much any changes that we make to it are likely to cause some amount of disturbance to people. So it's really tough because urllib3 is also very unlikely to be a direct dependency in user projects. Usually we are a dependency of a dependency. So a really quick background on what urllib3 is and what it does. urllib3 is an HTTP client library that was first published in 2008 as an extension of the httplib module in the standard library. And that's our logo on the right. So the reason originally that urllib3 was created was to make HTTP simple in Python. Starting in Python 3, which was actually released around the same time as urllib3 in 2008, the httplib module was renamed to http.client. This change, along with many other changes to the standard library, like the URL parsing library, many improvements to the SSL module, the whole bytes string Unicode change, it made it really difficult to write HTTP client code that was compatible with Python 2 and Python 3. The Python 2 to Python 3 code transition was really painful for a lot of users, and urllib3 tried to make its best effort to make that transition a lot easier for many of the libraries that needed to use HTTP specifically. urllib3 also provides additional HTTP functionality that at the time the standard library didn't provide. Things like certificate verification and different content encodings like gzip and brotli, and support for many different types of proxy. Now, this talk really isn't supposed to be about a ton of HTTP, but I'm going to explain a little bit about the importance of HTTP to give context to why urllib3 is probably the most downloaded Python package. So HTTP actually stands for Hypertext Transfer Protocol. It's a networking protocol that is best described as playing ping pong with 5 pieces of information. You send a request as a client, which contains a method, usually get or post, a target, which describes the resource that you're requesting or interacting with, some headers for metadata, and then optionally a body. Then responses contain status code like 200 OK or 404 not found, some headers for metadata, and optionally a body. Everything else about HTTP is built on these simple rules, but HTTP grew up to be one of the most important protocols ever invented. And it's unbelievable to think how much time and effort has gone into optimizing the transfer of these 5 bits of information across the internet. So many different things have been created because of HTTP's success. Many of us experience the internet primarily through a browser like Firefox or Chrome, which speaks HTTP. TLS, the most common way to secure a connection, was created originally by a web browser called Netscape to secure HTTP communications. Content distribution networks like CDNs, Fastly, Cloudflare, a huge chunk of their business is making HTTP responses faster because the speed of light just isn't fast enough for humans. And then DNS, another one of the world's most important protocols, is being made available over HTTP because it's easier to make an HTTP call from user space than a DNS request. And it's just easier to secure HTTP compared to DNS. And then most recently, Quick, very recent innovation made to replace TCP. The very first protocol that is being developed to run on Quick is version 3 of HTTP. HTTP is ubiquitous, it's everywhere. So now with some of that background knowledge about URLib 3 and HTTP, let's talk about why we're going through all of this trouble of releasing breaking changes. The primary reason is Python's HTTP story must be a good one. HTTP is such a vital part of software in almost every field. If Python is going to be a competitive language choice in those fields, we need to keep up with new innovations to HTTP. And there have been quite a few changes in the time that HTTP has been around. So HTTP 1.0 was published over 25 years ago in 1996. And shortly after, HTTP 1.1 was published. Fast forward to 2000, common name, a field on certificates, is deprecated in favor of subject alt name. Then in 2015, HTTP gets a new version, HTTP 2, which is a binary protocol instead of text and makes many improvements to latency. Just last year, TLS 1.0 and 1.1 were deprecated and began being removed by browsers due to vulnerabilities in earlier TLS versions. And then fingers crossed, hopefully this year, the final specifications for HTTP 3 and Quick will be published, completely changing the transport layer of HTTP from TCP to Quick. And this is by no means an exhaustive list of changes, but if we just want to take a look at this list and where URLib 3 is on it, you'll see we're currently speaking HTTP 1.1, and we haven't removed support for deprecated TLS and certificate features. We're not taking advantage of the innovations improving performance of HTTP, but we're going to start moving in this direction with URLib 3, v2. The green check marks is where we're hoping to be in the very first release of version 2.0 of URLib 3. The changes we're making in v2 will also make implementing HTTP 2 a much more realistic goal as well. This is a really big step for Python's HTTP story, and we're really excited to see what these changes will enable for our community in the future. So now that we know where we want to be, let's talk about how we're going to get there. So what really is changing in v2? I talked about dropping some deprecated security features, but what else? Here are a list of the big changes coming in v2. We'll be dropping support for Python 2.7 and 3.5. We'll be adding type hints to all of our public APIs. And we'll be ensuring modern security as our default policy. I'm going to go through each of these changes, talk about the improvements we're expecting to see, and what our team is doing to minimize the negative impact to our users. First off is dropping support for any Python version earlier than 3.6. In 2020, both Python 2.7 and 3.5 went end of life, meaning there will be no more security updates. In the time since then, many other popular packages have dropped support, including pip, our package manager. Our big motivations for this change are to reduce the maintenance burden. By removing these versions, we're way less likely to see and experience CI rot due to dev dependencies dropping support and us being left with an old version. We can also get rid of tons of backported code that we've been using to supplement missing features in the standard library. The best code is deleted code. We also get to take advantage of new language features that we've had to forego until now. Things like typing, F strings, and async are especially exciting. The downside of dropping support is we'd be leaving a large portion of our users without new releases. We'd be putting them in a tough situation, as security fixes are especially important for a piece of networking software like urlib3. If a project that depended on urlib3 wanted to continue supporting Python 2, they are then put in a tough position as well, with potential daemon dependencies. There's an option for marking your distributables as with a minimum required version of Python that helps installers like pip decide whether that package will work with the current Python version, but earlier versions of pip and setup tools don't know about this tag, so you may install version 2 of urlib3 on an unsupported Python version, which would lead to a really poor user experience. So how can we work around these issues? First off, we're going to be supporting security fixes for the time being on the 1.26.x branch of urlib3. We wouldn't be doing this without Tidelift, so big thanks to them and their subscribers for supporting our project for almost 2 years now. We've also reached out to large projects that are dependent on urlib3 and ensured that they understand what changes are coming in the future and what their support path will look like. Things like making sure they're pinning to version 1 of urlib3 explicitly will help stop unexpected breakages from happening to their users until they're actually ready to use v2. We also raise a helpful error message if we detect we're being installed on an uncompatible version. The error message includes instructions on what to do to resolve the issue. We're hoping that this makes the experience much better for users compared to just a random syntax error being raised when you go to import urlib3 for the first time. The second big change is we're adding type hints to all of our public APIs. One of the big motivations for this is that our API actually blends with the standard library's HTTP connection API. The standard library's API works great for HTTP v1, but it would be kind of tough to adapt to other HTTP implementations like H11 and for HTTP2 and beyond. Because we've been using the standard library for so long, it's tough as a user to know if you're using an API that the urlib3 team is actually pledging to support, or if you're kind of just interacting with an incidental API. So we're making things clear in v2 what our API surface is, so you can use urlib3 and not worry if things will change when we go to implement new features. Type hints won't change anything functionally, but we're hoping with the increased use of MyPy and other type checkers that projects that are relying on internal APIs of urlib3 will start moving away from those APIs always being there. In urlib3 v2, any new implementations of HTTP will be opt-in, so we won't have to worry about breaking anything that's already existing. And I think the biggest thing here is that for almost all of our users, even with a new HTTP implementation, nothing will really change. So you don't have to worry if you're only sending requests and then reading responses. The last of the three big changes is modern security by default. If you're wondering why I'm emphasizing by default, it's because almost all of our users will use the default settings. So make sure those settings are the right ones is really important to our team. We're planning on dropping support for common name on certificates. Now, this change is really tough because there are many corporate networks especially that haven't fixed their certificates. And we're expecting to see the most breakages in that space. Even though this change is removing support for a feature that was deprecated over 20 years ago, I actually feel like this one will be the one that causes the most kickback from the community. If you're wondering why I think that, the issue tracking the removal of common names is our most commented on issue, mostly fueled by users telling us that doing so would break them or that the change in question is pointless. This unfortunately isn't an isolated incident, as users acted similarly when Firefox, Chrome, and Go intended to drop the same feature that has been long deprecated. Security and usability are often at odds with each other, because by definition, security is disallowing some actions. Having to make decisions to balance the two is difficult, especially knowing that the millions of users whose security is improved and they aren't experiencing breakages, those users won't be the same ones that are in your issue tracker. We've been raising a warning for over 5 years now to prepare users for this change. In V2, we'll be converting the warning to an error message, pointing to documentation on how to generate certificates with subject alt name instead of common name, and as a last resort, how to opt in to continue using common name. Another improvement in the security area is to start discouraging the use of PyOpenSSL and the secure extra that yearlib3 provides. Previously, the SSL module was missing many important features, like server name indication, that were provided by PyOpenSSL. Now that the SSL module has all of these features, there's a lot less need to maintain more than one TLS backend than before. We're working with dependent packages to drop the secure extra and to stop using PyOpenSSL. One such project is requests, which actually stopped using the PyOpenSSL backend by default in the middle of 2020. And finally, we're planning on requiring TLS 1.2 and above by default instead of TLS 1.0. We're also a little lucky in that this will not be a big change for almost all of our users, and instead will only be a big security win. Most of the internet has already switched over to TLS 1.2, so we're not expecting a ton of breakages here. However, due to how tough it is to read certain TLS error messages, we're planning on providing a better error message with documentation on how to opt in to TLS 1.0 support if needed. Okay, so that was a lot of information about what changes are coming and how we're planning on mitigating breakages. What if I told you a lot of those mitigations had something in common? Almost all of them aren't code. This may be surprising at first, but when you think about breaking changes, you have to think about your users. And your users as a dependency are just people. The most important thing I can recommend is talking to people. Reach out to the community and the maintainers of other projects. Involving them in the process means that you might learn about things you hadn't even considered because they're the experts in their domain. Finding funding and allocating time are super important to all of these mitigations. In the end, someone has to do the work. Documentation is about as important as the code itself. If you can provide great documentation up front, there'll be fewer people confused, fewer people opening issues on your issue tracker, soliciting one-time advice, fewer questions opened on Stack Overflow and subsequently being answered by someone who might not be giving the best advice to your users. Writing documentation ensures that your users are making the right choices. Error or warning messages that include a URL are extremely important for cases where a feature has been removed or deprecated. If you put a URL to documentation or an existing issue, it lets you be in control from day one of what a user's next step will be. If it's a place where you can solicit feedback from users, you can also learn new things from users about how they're using your software in maybe ways that you didn't expect. And trying things for yourself instead of assuming things will work the way you expect is really important too, especially when it comes to being a dependency. yearlib3 already runs the test suites of our two biggest dependents, requests and Bodo core, before every release to make sure that we don't break the world. We'll be doing even more involved integration testing before V2 to ensure we're not breaking the Python verse. So with all this knowledge, what now? Well, if you have any extra questions about V2, you can catch me after this talk for Q&A. We've documented a V2 roadmap. We also have a community Discord channel where you can ask questions directly to the developers. Or if you're feeling inspired and you want to help out, there are many different ways to contribute. Most importantly, if you could try out the pre-releases of yearlib3 V2 when they're available, report any breakages you find, that'll help us a ton. If you or your organization relies on yearlib3, you can sponsor our team. We would really appreciate it. Finally, if you're into open source and you want to get your feet wet, we welcome documentation changes, code changes, anything that you're interested in contributing. I hope you learned something. Thank you very much.
Wonderful talk. There were so many things I learned there, quite a history to this project that you work on. Question, since we didn't get a Q&A time for you, is there a good place for people to contact you if they have additional questions?
Yeah, definitely. So if you have extra questions, you can either find me somewhere in the venue list. I believe, I'm not sure which one we're designating for that. But if you outside of this, you can contact me on Twitter. I'm at Seth M. Larson. And if you have any issues with your lib3, or if you have just general questions, we also have a Discord that you can join. You should be able to find that on the README or the documentation, and you'll get some answers to your questions there.
Perfect. That sounds awesome. Well, thank you so much again, Seth. To everyone else in the channel, please head over to our closing session. That is going to be in the interactive chat instead of in this this current venue. So we'll see you all there. I think we have a little bit of a break first, but we'll see you all there in a few minutes. All right. Thank you.